Michael Douglas discussing Chinese cyber misadventures there. And that brings us to our final discussion, insights on modern day cyber warfare. Please welcome Pukhraj Singh, product owner, cyber threat detection at BAE Systems Applied Intelligence. Thanks for connecting, Pukhraj. Over to you.
Thank you, Ashwin. Hello, everyone. So I'm going to present on the empirical paradoxes of security. It seems like a dense topic, but to understand the term itself, what empiricism means is that you base your judgments upon certain experiment, observation, and data. So I'm going to approach cybersecurity from an empirical perspective because I don't think it has been done that way. And when you see cybersecurity from an empirical perspective, you realize that many of the assumptions which our cybersecurity leaders are making, our CISOs are making, they could probably be wrong or at least slightly misguided. And it directly impacts how we take our decisions, how we take cybersecurity decisions, how we design our architecture, and how we understand cyber defense. Another title of the same presentation could be that what are the eternal truths about SolarWinds? So SolarWinds was a recent massive cyber attack against US government apparatus. So you could see the same parameters, the same ground truths, empirical truths also apply to SolarWinds as well. So the title is all open to interpretation. So a little bit about myself. I've got around 15 years of experience in detection engineering and threat intelligence. Roughly 5.5 years in the government. I call it the best of the times and the worst of the times. It was an interesting experience. What I've done is that I've put some emphasis on the geopolitical and the geostrategic parameters of cyber defense. So that gives me a kind of like an interdisciplinary perspective on cybersecurity, which probably applies to my presentation as well. Just so that you know that I'm quite eligible for presenting, I've trained senior military commanders on cyber defense and doctrine, so that you don't think I'm not sure if I'm skilled enough to present this. I've written for the US Military Academy, the US Army. There's one paper which is pending publication with the US Army. I've written opinion pieces for most of the major newspapers. The reason I'm citing is not to impress you. It's just that what I do is I try to bring complex topics from cybersecurity into the larger public domain. I'm an interlocutor. I try to offer simpler perspectives on complex things. So that's what I'm going to do in this case as well. So the presentation is dense technically, but I'm going to elaborate or elucidate that in a simple in a way which is more in a common sense kind of way. Forever a learner, I suffer from imposter syndrome. No matter how much you learn, you still feel like an imposter. So that's who I am. So let's move further. Now, I thought I'll carve a big agenda for this presentation, but I think this is the simplest agenda for this whole discussion or this monologue, if you may. Is we're going to get a brief glimpse into the broad empirical realities of cybersecurity, which are divergent from its operational parameters and assumptions. So it's again a very broad statement, a broad and sweeping statement. So we'll get on to what it means exactly. So just so that you know that I'll make some very broad statements and assumptions, but I don't have any solutions to offer, because these are such complex topics. I don't think a single person or a single entity or even a single organization or even a single government cannot offer solutions around these problems which I'm trying to explain here. So the first thing which comes to my mind is that we don't understand vulnerabilities very well. And vulnerabilities are the kind of like the building block of cybersecurity in a way. And it's almost like what the Higgs boson particle is to theoretical physics. Same applies to vulnerability and cybersecurity. So it's the fundamental particle of cybersecurity which we don't understand very well. So I'll try to go through its empirical parameters and try to explain why not understanding vulnerability is directly impeding our defense and capability and our architecture. So I'll start with a rather perplexing and a simple statement by Bruce Schneier. You probably all know who he is. He's a renowned cryptologist and author and a thought leader in our space. Thought leader is a term which is widely troped around in our industry, but he's actually a thought leader. So he wrote an opinion piece for the Atlantic, and he asked a simple question. It was like, are vulnerabilities dense or sparse? And it's a simple question. I mean, would you have more vulnerabilities in let's say 10,000 lines of code, or would you have lesser vulnerabilities? Because that directly affects our decision. And it sounds like a question which should have been probably answered 30 years ago, but it still hasn't been answered. So the reason why he was asking this question is that if the vulnerabilities are sparse, let's say for 10K lines of code, if there are fewer vulnerabilities, then you can obviously find each vulnerability and fix it, because fixing vulnerability is expensive. I mean, as we speak, Microsoft is fixing the Exchange 0 day, and probably Google is fixing some Chrome 0 days. That effort probably entails couple of $100 million of effort across the spectrum, right from delivery of patches to its deployment across various organizations and companies. So if they're sparse, we will fix it. It's all good. But if they're plentiful, if the vulnerabilities are dense, then fixing each one of them is not going to solve a problem, because we need to invest our focus and energy somewhere else, because it is not going to change the threat landscape at all, because there are too many vulnerabilities, and you just can't spend millions of dollars patching each and every one. So what is the answer for this paradox actually? But before we go there, what does the industry would like us to believe, the cybersecurity industry? Of course, the cybersecurity industry, in a nutshell, would like us to believe that vulnerabilities are sparse. So, in a sense, that we have to fix each and every one of them, and gradually and incrementally, our cybersecurity posture would also improve. Is that the case? I mean, what we're seeing right now, 20 years down the line, I think buffer overflows are what, like 25, 30 years old? And there's a joke that SQL injection is old enough to get a drink at a bar. So we are dealing with 2 decades and 3 decade old vulnerabilities, but still they keep on just coming and coming. So the industry would of course like us to believe that vulnerabilities are sparse. So I kind of like posted this to Chris Weissapal on Twitter, and Weissapal is actually, he runs the most popular application security testing company in the world. He's a renowned hacker as well, and he gave me a reply that with a great secure SDLC, there's a chance that the vulnerabilities are sparse, but it is rare. Now, that's a big statement. I mean, there's so many, caveats to the statement, or so many so many conditions to the statement. Great secure SDLC. Nobody knows what that means really. I mean, unless you are a company fully invested into that. So we could probably assume that maybe vulnerabilities could be sparse, but at least as of now, we don't understand its parameters well. So maybe they are dense. So again, a simple question, but such a complex answer that we can't even understand that dynamic, or that empiricism 30 years later. Okay, now just so that you understand, I mean, it's such a complex problem. The Dan Gier, who is the Chief Information Security Officer in Incutel, which is a CIA-funded venture capital organization, a pretty popular one at that, which pioneered many cybersecurity companies like FireEye and ArcSight and others. And he says, basically, first of all, if you need to know if vulnerabilities are dense or sparse, you need to understand how many lines of code are we producing annually. And he said that problem is actually almost like is equatable to theoretical physics in a way, or the cosmic science, the science around our cosmos and galaxy. As I mentioned, that vulnerabilities are kind of like the Higgs boson particle, and it's one of those fundamental traits of our cybersecurity universe. And my empiricism is approaching the science of vulnerability from, let's say, from the perspective of theoretical physicist. So I think this kind of like analogy applies to me as well. I'm not an actual exploit developer. I'm a person who studies the empirical data around exploits and vulnerabilities. And so I'm kind of like an theoretical physicist studying this domain. So he says that, it's almost like finding a livable planet across galaxies. The calculations almost are comparable to that. I'm not going to go through the whole text, but that's what he's stating in this paper. And just so that you know, that all the references which I've cited in my presentation, they're available at the end of the presentation. You could always open those hyperlinks and check the papers I'm citing. Another excerpt from the same paper by Dan Gier. He says that, let's just say now we figure out, okay, this is how many lines of code we produce in a year across the world. And then out of those lines of code, we encounter, let's say, these many bugs. This is the average percentage of bugs in a certain lines of software. Now, another question arises: how many of these bugs are actually exploitable? And that's where the whole argument almost becomes like quantum physics in a way. It really depends on the observer. Like Chris Weissopal, whom I quoted earlier, who runs Veracode, the application security testing company, one of the most famous ones in the world, he says that there are only a few percentage. There's only a few percentage of bugs which are exploitable, which become vulnerabilities. On the other hand, Dave et al., who's a former NSA hacker and an exploit developer and a person who's really respected in this industry, he says that exploitability is subjective. Someone or the other would be able to exploit a bug which might be looking unexploitable to the other person. So that's a tricky part here. It's we are entering into a territory which is so vague and so ambiguous. It really depends on who you are and how do you see your data. And we don't have much data basically at this level. And it really affects our decision making. All the CISOs in the world are making certain decisions on investing certain things on certain money on vulnerabilities and patching and all that. But is that investment justified? Just an example, actually. So that's why I'm talking about this lopsided vulnerability science. And so Maddie Stone, who works at the Google Project Zero, which is known for finding 0 days and sort of disclosing them, and says that there's a detection deficit and how it impacts cyber defense. What does she really mean? She says that the number of 0 days. I'm not. First of all, I'm not very fond of 0 days per se. I don't think 0 days are an accurate marker of your vulnerability or your invulnerability. But she says, sorry, I'm not sure if I quoted her as a he or a she, but she's a she for sure, and one of the most pioneering women in cybersecurity. And she said that we probably haven't stumbled upon enough 0 days in the wild, so our data is actually quite skewed. And that's a phenomenal statement coming from a person who works at Google, because they are probably sitting on the largest telemetries which can possibly detect complex cyber attacks, including 0 days. So again, our sciences are diverting and becoming highly subjective, and this is totally driving our detection. I'll tell you how. Let's go further into the presentation. So Maddie Stone, she writes further, and I'll just summarize this sort of paragraph in my own way. She says that maybe we feel that Microsoft has more 0-day vulnerabilities, and maybe other platforms don't have so many of them. But that again it could be a subjective bias introduced by our data sets. Maybe we detect more 0 days in Microsoft because now Microsoft's cybersecurity architecture has advanced enough over the last 20 years. We have got our EDR, we've got our antiviruses. Microsoft itself has a huge telemetry capturing mechanism. So maybe it's just that we are detecting more 0 days in Microsoft than any other platform. And if you compare this with let's say the detectability of in mobile platforms like Apple, iPhone, and iOS, you could understand that maybe our assessments about the relative vulnerability of, let's say, Mac OS compared to Windows, compared to Linux, is not sort of falling into place because our data sets are skewed. And you can understand this really affects our threat posture, right? Our threat perception. Now, I'm going to give you a couple of examples how it really hits home. So again, not going too technical, but there was a recent, quite a damning bug or a buffer overflow discovered in sudo. Sudo is like what? It's like the is the command which of course exists in any Linux or Unix operating system. It's so prevalent, it's so widespread that if it breaks, then everything breaks across the internet. It's that kind of vulnerability. And basically, this was a vulnerability in an application which provides you elevated privileges on the operating system. So quite a damning vulnerability. And it seems like this vulnerability was unnoticed for almost 10 years. And that's phenomenal. You can imagine how many systems were compromised by certain actors using this vulnerability. And we only discovered it accidentally just recently. And so this person was like, okay, if we were to fuzz this vulnerability, if we were to, let's say, discover this vulnerability in a usual process, what we call fuzzing, how long would have taken? He came to a conclusion maybe 2 to 4 hours. but still the vulnerability left undiscovered for 10 years. So my question is even our vulnerability discovery working? Are we discovering the right vulnerabilities? And our discovery and an attacker's discovery are disjointed. They could be Venn diagram. I mean, there could be certain overlap, but these could be completely disjointed paradigms actually. So we are not our vulnerability science as a defender and the vulnerability science of an offender could be completely disjointed, and that's phenomenal, in a way. Let's see it from some other perspective, the vulnerability discovery process. So this screenshot is just from yesterday. So there seems to be a privilege escalation bug in Linux again, in like very old code for iSCSI, and it basically bypasses every defensive mechanism on the Linux operating system, from KSLR to SMEP, SMAP, and all that. And it seems like this vulnerable code was introduced 15 years ago. And so these systems, I mean, and Linux is like now, it's like the dark matter in of our universe, because it's everywhere. It's like in our IoT devices, in the Android system itself. Most of the every connected device now. I think in terms of presence and market share, Linux has definitely taken over Windows very easily by certain scales and certain margins. And so having this code existed if this code had existed for 15 years, you can imagine that a vulnerability discovery process is also not working, and it directly guides our skews our defensive paradigms. Now we are so focused on Windows or I don't know what, identity and exchange management, zero trust, but some of the fundamental building blocks of the universe or cybersecurity universe seem to be totally skewed. Let's see another way of looking at it. So Maddie Stone, she wrote another post that so out of 24 zero days which were detected in the wild in 2020, 6 were closely related to publicly disclosed vulnerabilities. So what does it mean from an exploitation perspective? So what really happens is that when a vulnerability gets disclosed or is discovered some way or the other, the company, the owner, the vendor would start fixing it. And sometimes they're not able to find the root cause of that vulnerability in an accurate way, because possibly because of the paucity of time, but also because of the paucity of skill set. Maybe the programmer itself doesn't know what triggered the vulnerability. And so, in fact, it's you may not realize this. We are so quick to apply patches, right? We would like to apply patches for Exchange or whatever comes, whatever new zero-day or vulnerability comes. But maybe these patches are not working at all. That's what, or not working in quite a few cases. That's what this blog by Maddie Stone is implying, is that in fact, we are not properly even addressing the vulnerabilities, because attackers are basically can go to the same attack path or the code path, slightly tweak the attack path a little bit, and arrive at the same vulnerability. In fact, there are always cases as well where if you find one vulnerability, there could be chance that there could be another vulnerability in the vicinity of the same code. So now you can imagine how skewed our dynamics of vulnerability discovery, our vulnerability understanding, what the vulnerability sciences are. Let's move further. So another post, just a case in point, is that this person whom I retweeted on Twitter, and he says that personally, almost every single bug I've reported internally has been incorrectly fixed. And you can imagine, if you're not fixing them correctly, if we can't rely on vendor patches, what do we rely on? We can't rely on anything, because the attackers would know this. When they reverse engineer the patches, they would know, okay, the vulnerability probably wasn't fixed, and they would create a new exploit for it, and it goes on and on. So again, it comes down to what is the definition of a vulnerability in the first place. I've talked a lot about vulnerabilities. What is the definition actually? In fact, we don't have a definition. It's very difficult to derive a definition. I'll quote the second paragraph from this statement by Sergey Bratus, who's a professor at Dartmouth. And I'll just quote the second paragraph. He says, advanced exploitation techniques are rapidly moving towards the boundary between bug and expected behavior. What he's saying is that the difference between a bug and a feature is almost closing in. It's like almost indifferentiable. It's like you cannot distinguish between that. And when advanced exploitation is moving towards that level, you don't even know what a vulnerability is actually. It's like your signal and noise are all mixing up. It's becoming that complex. Is our enterprise security architecture or are our CISOs, are they understanding these fundamental traits of vulnerabilities that they actually just look like normal system behavior? I would also recommend, I don't want to make this discussion too complex or too technical, but you could also go through Halvor Flake's presentation on weird machines and exploitation to really understand how exploitation works at the state machines level. And you will probably realize that vulnerabilities are not like a alien hostile code which is introduced onto your systems. It's basically your own system working slightly different from the expected way. That's about it. And so how do you detect it? It's very difficult to detect it because it almost may be it may look like baseline behavior or normal behavior. And you can understand how this totally disrupts our ground truths of offense, defense, and and whatever the new fancy paradigms of cybersecurity are. Now, another case in point in how do you define a vulnerability in the first place. So I'll just quote from Aaron Adams. He's an ex-colleague of mine, one of the possibly the best vulnerability researchers out there in the industry, and he says one aspect of modern exploitation is that the more aggressive defenses and a better general understanding of low-level technologies seem to have pushed research and techniques to what is almost the fringe of what can be classified as an explicit hole or flaw. And he further states that what is especially interesting is that these techniques is that not only they start to blur the line of traditional vulnerabilities, but in many cases, the vendor response is not to fix the underlying issue. Sometimes software vendors are unable to fix the bug. So again, drilling down on the same theme which I discussed earlier, that first of all, the vendors actually are not even understanding what the vulnerability is. They're not supplying the right patches. And secondly, your vulnerabilities could just be they could look like normal system behavior. That really makes our job extremely difficult. So I again go to Sergey Bratus, the professor at Dartmouth, and I'll skip down to the second paragraph. Just need to pay attention to just the second paragraph. And okay, let me quote the first one, the first paragraph, first, because I think there's an important statement there. And he says that complex software, and I think, what do you mean by complex software? I think even the most simplest of software right now are quite complex in a way. I think we have gone beyond the age where you could build a monolithic, system or a software in with a single file of code. Every software is almost complex as anything as they could be. So complex software is built in multiple levels of aggregation and composition. And innovation in software basically entails aggregation and composition of unforeseen combinations at many levels. So basically what he means is that to create effective software nowadays, you use software to create software. So if you want to introduce automation in software engineering, you use software for that. So he basically says what he's basically explained that in the second paragraph. He says that the hooking pattern is just one example he gives the engineering operation of composing software with other software. So one example is that you compile your own software using the compiler. So you're using one software, which is the compiler, to build another software. And so when this happens, there's so many layers of abstraction and so many layers of, let's say, interconnections and aggregation, that you don't know where your software begins and where your dependencies expand to the wider software ecosystem. And that's our functionality comes from, actually. So just pay attention to composing software with other software, because my next slide is incumbent upon that. So in fact, this ground truth was explored way back in 1984 by Ken Thompson. So Ken Thompson is, as you may know, is one of the founders or the let's say the architects or the key ideologues who created the Unix operating system. And he was about to give a speech somewhere, I think for a certain award he got from ACM. And he gave a kind of a speech, an impressive speech or paper on trusting trust. He was like, can you actually trust your trusted interfaces? What it really means is that, can I trust so I'm using one software to generate another software. So can I trust my compiler? Can I trust the libraries which I import? Can I trust my supply chain in a way? Supply chain is one more. Software supply chain is an example of this kind of implicit trust, or what we call transitive trust in computer science. And his model was, unless you've written every line of code manually and inspected it, you can't trust anything. And that basically makes all the software which we have developed in the modern age untrusted. And that's where the foundational ecosystem on which vulnerabilities, from which where the vulnerability come on, this is where the vulnerabilities are coming from. These layers of abstraction themselves are the wellspring of vulnerabilities. So just the mandatory Gluck quote here. So I'm trying to explain a concept here. The SolarWinds supply chain attack happened, and so Gluck posted a sarcastic tweet, and he says that if you really want to understand the SolarWinds supply chain attack, you can refer to this certain paper, and this paper is the same paper which I quoted earlier. This one, Reflection on Trusting Trust. It's a tongue-in-cheek remark that we have known about, or we know about this complexity of software producing vulnerabilities for the last so many years, since 1984. And so the key takeaway from this is that vulnerabilities are not, they don't exist in a binary state. It's not like either they are there or they are not. They are a product of complexity. They are a product of emergent phenomenon, as in they may or may not arise when all your systems, which are so dependent upon each other, all the interfaces and all the layers of abstraction and all the layers of aggregation, when they start interfacing with each other, that's where the vulnerabilities come from. And that's why it's almost nearly impossible to, let's say, detect attacks like SolarWinds. I mean, we could possibly now get some advances, make some advances on supply chain. The supply chain is just a case in point here. Is the idea that complexity itself is the wellspring of vulnerabilities, and we don't know how to fix it. We just don't know, because our software is becoming more complex. And I'll give you more examples, some more earth-shattering truths about it. So we can skip this slide. I'll come to one of my favorite hackers out there. So Mudge, he's a legend in the industry. He's a chap who, in 1999, he testified in the U.S. Congress that his team could break down the internet in 15, 20 minutes using a hole in the BGP protocol. But after that, he worked with DARPA, the agency which created the internet. And so he's a phenomenal person, a path-breaking, philosopher in our space. And he gave this presentation. It's one of my favorite presentations out there. He gave this presentation in 2011, and this graph is outdated, but it drives home a point, and I'll just explain it very simply. So the graph, that rising curve which you see, the blue curve which you see, are the number of lines of code in security software from 1985 to around, let's say, 2007 or 8. So you could see that after, let's say, around 1997, the number of lines of code in security software are increasing dramatically. But if you see the red line, almost like a flat line at the bottom, that's the number of lines of code, average number of lines of code in a malware. So what this really means is that the number of lines of code in your security software have been like increasing exponentially almost. But the complexity of the attacking code has not increased. So the job of the attacker has remained as complex as it was, let's say, 20, 30 years ago. And maybe the same lines of code can still compromise your network, which used to compromise, let's say, 20, 30 years ago. So what is the problem here? The problem is that if the security software itself is introducing more complexity into the IT ecosystem. In fact, security software itself could be the source of many vulnerabilities or the source of complexity, which further makes your networks and software insecure. It's a very paradoxical, counterintuitive statement, and that is what is driving home. I'll give you another screenshot from the same presentation, and just focus on that text which I've highlighted in red. And he says that for every 1,000 lines of code that we introduce, we also introduce 1 to 5 bugs. And maybe out of 1 to 5 bugs, maybe 1 or 2 are exploitable. 1 or 2 are actually are vulnerabilities. And the same applies to security software. I mean, security software is almost the same as any other software. We have our own dependencies. We use the same libraries. We render the JPG image just the same way as any other software would render a JPG image, probably using libjpg. And so we have the same dependencies, we have the same layers of abstraction, we have the same layers of aggregation. So why would not our security software introduce more vulnerabilities? So basically, your security software itself is actually the source of many security issues. Counterintuitive, and this is an area which has been least explored in our realm. In fact, the responsible when you find a bug in security software, the chances are you'll either be silenced or someone will file the security software vendor would probably file a lawsuit against you. So that's the nature of the beast we're dealing with. Who is going to watch the watchers? Who is going to observe the observers? Who is going to police the police? We don't know. And the challenge lies there actually when you deal with nation-state level attacks, or when you deal with APTs. I think the the fundamental shift is happening in that direction. And SolarWinds is an obvious example again, because SolarWinds itself is kind of like an IT security administration software, which became a source of vulnerability, and it was a horribly managed code, and it could escape the purview of your regular security processes because we just assumed that security software are meant to be secure. Well, maybe we need to revisit those ground truths as well. So another post by March. Again, I'm just gonna just screenshot a couple of posts by March, one of my favorite hackers out there. So he says the Department of Defense data shows that on an average, 1/3 of vulnerabilities in government systems lie in security software. Again, a case in point, quite damning. Now you think about your own cybersecurity architecture. All those vendor systems, the black boxes which you're running, are they really immune, or are they actually the beachhead for an attacker? So another possibly, I think this is the last post, last screenshot from Maj's tweet. He says that now I'll come down to now. Mitre Attack is a very popular ontology, a body of knowledge in our industry. What Mitre Attack is that it aggregates our understanding of what the attackers are doing, their tool, their tactics, techniques, and procedures. Again, what does it rely on? It relies on certain assumptions, certain data sets we have. And now if our data sets are not accurate, maybe our body of knowledge would not be accurate as well. So just the case in point. I'm not saying Mitre Attack is ineffective. I'm just saying that it could have certain edge cases, or it may not be full-fledged system to be solely dependent upon. So in this case, Mudge is saying that what you may presume are dependent events in your network. Let's just say you might say that, okay, there was certain event A which got triggered on your network, and there's a certain event B which got triggered on your network. They might seem unrelated to you, but they could be dependent even for the adversary or the intruder. And we don't know, and so we don't map these dependent pathways based on an attacker's imperatives or attacker's limitation. We map it largely based on our understanding of the attacker and not the actual operational imperatives. And it's a challenging exercise, but just the case in point of that there could be possible, gaps, not gaps, but edge cases for Mitre Attack, which possibly no one is even talking about. You can explore this Twitter thread further. There's a very interesting line of argument which is happening on this Twitter thread. You can always explore it. Okay, I'll come to another person who I really admire, Hostile Spectrum. He's basically Professor J.D. Work. He teaches at Marine Corps University. We interact a lot on Twitter. And now we assume that attackers TTP work certain way. There's always gonna be a command and control server. There's gonna be a mothership, and there would be some amount of reconnaissance, all that, the kill chain thing. Maybe not. And he predicts, and we've been discussing that that we have foundational assumption that there will always be a command and control server. There will always be some communication happening with the mothership. Maybe not. I think the future of, let's say, cyber offense are autonomous, wormable payloads with complex targeting with extensive modularity, what I really mean is that these worms would be like autonomous systems, which would do their own targeting in your network, would not talk to the mothership, take its own decisions, and possibly rely on certain operational pivots which are not accounted for in our kill chain. And so what it totally disrupts our enterprise security architecture and our assumptions. So what do we do with it? I don't think we can do anything about this. So imagine a SolarWinds kind of attack, but fully automated. So, and this is not like something which is far out in the future. This is actually this is happening as we speak, but it might just become very widespread. And so, how do these assumptions, empirical misassumptions, if you may, extend to other areas? I'm just going to give you some more examples as to how these misassumptions apply, or how do they skew more areas of cyber defense. So I've been reading this book. I read this book on bootkits and rootkit. Fascinating book actually, which really I went through the lowest layers of the exploitation services, the ring -2 component, which is below the kernel. So we created very nice systems to deal with firmware security, UEFI, Intel Boot Guard, all that. But the way our vendors have implemented that has completely botched it up. It's completely botched up. And so this is one example of that our lack of understanding of the baselines of offense and the empirical assumptions behind that is completely misdirecting of it. We should be focusing on this, the complete vulnerability of our firmware and the ring -2, sorry, the ring -2 layer. Then let's say talking about something fancy as AI, ML, or zero trust. This is where and there's not even an observability platform which could detect these attacks. So once the attackers have compromised your firmware, I don't think there's any security software which could really detect an intrusion. So it's all out open for the taking. Another example, just a statement by Grok: your perimeter is not the boundary of a network; it's the boundary of a telemetry. So we rely on our perimeters. I don't think there's a thing called perimeter actually anymore. It's basically your perimeter just defines how much data you're getting. It does not define that your network, because your network is basically all the layers of dependency and abstractions which go out. SolarWinds is one example. So the targeted organizations, they were connected to the vulnerabilities of the SolarWinds company via this weakest link in the chain, which was the SolarWinds software itself. So you don't know where your network goes to. And just the example of how even the foot soldiers of a cyber war, the antiviruses and EDRs, even 30 years down the line, they're so easy to bypass. Again, our ground assumptions are possibly, we rely so much on these software, but somehow, are they really up to the mark, or are they something to be relied upon solely? Just a question and some references on that. And these bypassing techniques are latest. They're like I just released a few months ago. Same applies to attribution. Our data sets are completely skewed. So if you want to attribute a cyber attack, our data sets are skewed in many, many ways. It's an interesting paper which got released recently. You can have a look at it. But in general, the summary is our threat intelligence itself, the nature of threat intelligence, is governed by these skewed data sets. Our attribution is governed by these skewed data sets. And in this paper also, the author of the paper cites that most of our data sets actually completely skip the Western, in quotes, the Western malware. The only malware, the most of the data sets are populated with Russian, North Korean, and Chinese malware. So there's a major geopolitical bias towards certain data sets. And so that really is not a true marker of a vulnerability or invulnerability. And so just a kind of like a tongue-in-cheek remark, who takes care of Ambani's iPhone? I'm not sure if Ambani has an iPhone. I just wanted to make a sensational remark. But the point I'm driving is that you may probably know that it's very difficult to do forensics or detect an attack on iPhone. It's such a closed ecosystem that we can't really detect, and it's quite challenging. In fact, only now that we have software to do forensic analysis on iPhones, like ZecOps is one, but the whole ecosystem is quite closed down. So maybe we are completely, an attacker would know this, and so the person would not focus on your massive industrial scale enterprise security architecture. They would just target the weakest link in the chain. And so do we understand these dynamics and account for the threat perceptions which emanate from these empirical parameters or empirical paradoxes, which are completely antithetical, completely opposed to all the assumptions which the CISOs, our security architects, or cybersecurity industry is making. And that largely sums up my presentation. I hope you enjoyed it. And I don't think there are any further slides, just some references to some papers which I cited. You can have a look at them. You can always go to the tweets and follow me on Twitter as well. Be mindful of my political leaning. People think that left-leaning people think I'm slightly right of center, and the right wing think that I'm maybe too left of center. So just be mindful of that. But you can always follow me on Twitter for these interesting insights. Thank you very much.
And with that, we come to the end of day one of the DynamicCISO Summit 2021. This event was enabled by our partners Trend Micro and our gold partners Fortinet, Sophos, CrowdStrike, and Quest. Now, our conversations will remain alive on the hashtag CISO Summit 2021. And tomorrow, we will commence day two at 1 p.m. And we will be capping this year's event with the annual DynamicCISO Excellence Awards 2021. Till then, take care and stay safe. And with that, we come to the end of day one of the DynamicCISO Summit 2021. This event was enabled by our presenting sponsors Trend Micro and our gold partners Fortinet, Sophos, CrowdStrike, and Quest. Now, our conversations will remain alive on the hashtag CISO Summit 2021. And tomorrow, we will commence day two at 1 p.m. And capping this year's event will be the annual DynamicCISO Excellence Awards. Till then, take care and stay safe.